we've got to the point with vectors where we've pretty much learned all of the skills, okay? We've learned scalar dot product, we've learned three-dimensional, lengths of lines, all of that kind of stuff. And really, there's now like 2 sections of things that we're going to do. One of the sections that we're going to do is problem solving to be able to tackle all of these different things that we've got written here. And then the second thing that we're going to do is problem solving in worded questions, okay? There are all of these different things that we would need to know how to do. So the ones I've put in green are finding angles between certain things. The red ones are all to do with intersections. In other words, where do things actually cross each other? The blue one is all about shortest distances. And then obviously the last part here is to do with reflections, okay? What you will eventually be doing, and it's worth me telling you this now, is there will be some questions that are like real life questions. I looked at a question recently that was about a tent, and it said, like a tent that you go camping in, it said the 2 sides of the tent are being modelled as these planes. Like there's a rope from one corner of the tent going like to the shortest distance to the ground, like where does it hit the ground, like as a coordinate, how long is the rope? So you can already hear some of the things I'm saying. You've got 2 planes that are the sides of the tent where they intersect. You've got a rope as the shortest distance between a line and a plane, or point and a plane. Have I got that? The shortest distance between a point and a plane, that might be like the top of the tent where the rope is starting, and the plane would be the floor. So that's what we try and do. When we see these worded questions, they are just these things, but just with words mixed in with them, okay? So there's not going to be anything other than these things that I've got listed here. So we're going to spend, I think today, we shall probably do these 3 green and maybe the first one of the red. And then this is a larger part of the topic. This will probably take us like a couple of lessons to do the shortest distances. But please bear in mind, these will usually be in the context of worded sorts of situations, okay? Problem solving kind of things. But they're not really problems because they're just doing those things. They're like just these questions in disguise, okay? So the first thing we're going to look at on that list is angles between 2 lines here. So I've got this diagram, and if I wanted to find the angle between these 2 lines, so the 2 lines I'm talking about is this and this. The angle between those 2 lines, what aspect of those line equations do you think I would use? Do you think I'd be interested in A's, the D parts of it, both parts of it? What do you think is the thing that's going to help me find the angles of them? The D parts, the interesting parts, because they are the directions of the line, okay? The D parts are this and this. So this part and this part are useless for helping us find an angle between 2 lines. The only thing that I'm interested in is D1 and D2. So I've said here, to find the angle between 2 lines, you find the angle between their direction vectors, i.e. we only care about the directional part of the line, not how we got to the line. And hopefully that makes sense, right? This shouldn't be something you should memorize. This should be something that should make sense. And then we're going to do a little practice question together. And then I'm not going to ask you to do some practice after that. We're going to learn all of the stuff first. We're going to learn all of the green bits. And then you're going to be applying it, okay? So, can I start going through this example, do we think? I'm going to try and squeeze it in on this page. I don't think I've given you much space to do this, but we can fit it in, I'm sure. So it says the points A and B have position vectors blah, 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 and blah, 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 respectively. The line L1 passes through the points A and B. Okay, nice and easy to begin with. Find the vector AB. Well, we know that the vector AB is B minus A. And B is this one, which is 3, 4, 1. And A is 2, 6, minus 1. So we get 1, minus 2, 2. Just with the subtractions there. Being careful of negatives and things like that. Part B then says, find the equation of the line. Okay, well this is baby stuff, right? What's the equation of the line? R equals either of those. So let's do the first one that my eye looked at, 261. And then AB, 1 minus 2, 2. There's an equation of the line. Yes, correct. And we didn't have to use 2, 6, minus 1. We could have used 3, 4, 1. And we also didn't have to use 1 minus 2, 2. We could have used 100 minus 200, 200. Anything as a multiple. It then says a second line, L2, passes through the origin and is parallel to the vector I plus k. The line L1 meets the line L2 at the point C. I've cut off the rest of the question that asks us to find the point C. All I've asked, though, is to find the angle between L1 and L2. So the things that I'm interested in is the direction of this line and the direction of the second line. The direction of the second line is what as a vector, column vector? 1, 0, 1. So all I need to do to be able to find out the angle between them is use the fact that the cosine of theta is, who remembers the formula?
A dot B over the modulus of A multiplied by modulus of B.
And because I want the acute angle, any suggestions of what I could do? You can either do 180 minus it, or if I want to guarantee I get an acute angle, I can modulus the whole thing. If you want to guarantee that you get an acute angle, right? Now, obviously, A and B here have got nothing to do with A and B up here, so that might be a little bit confusing. This is, if I put these inverted commas around it, that's just saying, like, this is the formula. Now we're actually just going to do it with our values. So we get that cos theta is equal to, well, let's dot these two things together on the top. We've got 1, 0, 1 dotted with 1 minus 2, 2. Doesn't even look like I need to take the modulus there, does it? I'm not going to have a negative value for this. All divided by, the modulus of this is root 2, and the modulus of this is 3, because it's root 9. So we get that cos theta is 3 over root 2 times 3, which is just 1 over root 2. Yep, but do you remember from GCSE, did you memorise what these were? You should have memorised them.
I did. I can't remember.
Okay, so this is the one you should know.
45.
Very good, Ishak. So theta is 45 degrees. So the angle between these two lines is 45 degrees. Didn't even touch a calculator, did we? So I squeezed that in there. I've told you which questions from exercise 9D are the angles between two lines, but I'm not going to ask you to do them in this order. I'm going to just give you the exercise and you're going to have to jump around the next few skills that we've got, okay? So we're going to move on, and we're now going to look about the second thing on our list, which is the angle between a line and a plane. So the only thing that you need to know here is it's just about the directional vectors. That's the only thing that we're interested in. So this time, we want to find the angle between a line and a plane. Okay, so I've got these two different diagrams that I've got here, and I've got this plane. This plane, I've clearly been given the n that I have over here, the normal. We obviously need to know what the normal is. And I've also been given this line. And what do you think B represents on the line? What do you think the vector B is for the line? Good, it's the direction. B is the direction of the line. So our line is probably something like R equals A plus lambda B. And this, our plane, is just R dot N equals P. So the things that I'm interested in are N and B, okay? Now, if I found out what N and B are, I would usually be finding this angle in here. It's creepy. I would usually be finding this angle in here, but we're going to try and look at it in a different way. I'd prefer to draw it on this diagram. It's just a little bit easier for us to draw out instead, okay? I just need to make sure I'm going to explain this in the right way. Okay. So I'm not going to use this diagram anymore. I'm going to use a kind of flattened diagram. I just find it a bit easier to draw. So this vector here is B. And this vector here is the normal one. Now, if I was going to find the angle between them, the one I want to find is this one, right? But actually, the one that if I just did my cos theta is n dot b over modulus of n modulus of b, what angle would that tell me?
The one in bottom.
Yeah, it would tell me this one.
It works out one, both the directions.
Yeah, it's actually going to tell me what that angle there is instead. So I don't want to know what this angle is, I want to know what the other one is. Now there's a special relationship here between theta and alpha. And I'm going to just tell you what this relationship is. So at the moment, we know that the cosine of alpha is n dot b over modulus of n modulus of b. And if I want to make sure it's acute, which I do, I would do this. Now, let's just do something a little bit separate over here for a second, okay? Here is a triangle, A, B, C. It's 90 degrees. I'm going to call this angle down here alpha, and this angle over here theta. I'm actually just going to pause for 1 second. Obviously, you could just find out this angle, and you can just see it's a triangle and do 180, take away 90, take away that angle, and just get theta. Okay, you could just do that, but I want to show you something that just is one thing, does it all at once. Okay? So you can technically find this angle that's here by doing it between the normal and B, find out what that angle is, take it away from 180, take away 90 as well, and you get the angle between the plane and the line. But instead, what is cos alpha from this? What, using like adjacent and hypotenuse and things like that. So what is it? A over C. What else is A over C? This time using theta instead of alpha.
Sine theta.
Good. So cos alpha is the same as sine theta if alpha plus theta is equal to 90 degrees. Because this is the adjacent over the hypotenuse, this is the opposite over the hypotenuse. It's just referring to a different angle. So this means, instead of saying cos alpha, because I don't actually want alpha, I can instead replace it with sine theta. And this is the formula that we'll memorize, okay? That's the angle between a line and a plane. And if that was drawn on this diagram here, this one would be alpha. That's the one that we would initially have found between N and B. And if you want to find the other one, you do 90 minus alpha. That's the same thing as doing 90 minus alpha, because clearly these all add up to 180. So these ones both must add up to 90. It's just a slightly different diagram that's been drawn there, but it's, you can imagine how all these are. If I added in, that one would be alpha, that one would be theta. You can see all the kind of the symmetries of those angles that we've got there. So instead of finding the angle between them, if I want to find the angle that's over there, I change it from a sine to a cos, and it will just give you the angle that you need immediately. By putting those modulus lines on it, it'll always give us the acute angle, which is the one that we're actually interested in. So this one, sorry again, I don't think I gave you much space to be able to do this. We need to find the angle between this line and this plane. Who thinks they can remember how we can translate this from Cartesian to parametric? So R equals minus 1, 2, 3. Okay, good. And what about this one? What's the value of n from this? 2, 3, minus 7. Okay, so now we've got those two things. The question is just super easy. So if I want to find out sine theta will be this one, the direction, and this one. So it will be 2, 3, minus 7, dotted with 2, 1, minus 2. I don't even need to take a modulus here. Over root 62 multiplied by root 9. I think I've done that right on the bottom. Is it root 62? 49. 49 plus 9 is 58, plus 4 is 62, multiplied by root 9. And what's the numerator going to be? What's the numerator? 21. So it's 21 over 3 root 62. So theta will be whatever we get when we do that on the calculator. I guess I should actually get my calculator out rather than just hoping it's just going to magically all get done in my head. So I got that theta was 62.7 degrees. So 2 lines, same as before. Line in a plane changes to the normal and the direction, and it changes to sine. We're going to do the last one of that. We've done 2 lines, done line in a plane. The next one is going to be the angle between 2 planes. Am I okay to go on to the next bit, or do you need some time just to finish writing this? All good? So now we're going to look at the angle between 2 planes that we've got here. Now, this is why the parametric is not as useful. This is why the normal version is useful, because it allows us to do all this kind of problems that we've got here. So here is one of my normals. Here is one of my other normals that I've got here. And I'm going to try and find out this angle that we have, right? Now, we know that if you're going to find the angle between them, which angle would it be if you did n1 dotted with n2 divided by the modulus of n1, the modulus of n2? Would it be 1, 2, 3, or 4?
3.
It would be 3. It would be this one over here, right? So when we find that one out, I'm just going to call that one alpha, which is going to be the same then as that one over there, which is alpha. What do you know about the size of theta and the size of alpha? They equal to 180. Why? Good, because this is a 90, and this is a 90, and a quadrilateral is 360. So these must be 180. So what can you tell me about this one here? What's that angle?
That's going to be 180 minus 90 minus.
What have you got here? Look. That's alpha. That's a red straight line. 180 minus alpha.
Where does it get theta?
It's theta.
Oh, yeah.
So that angle there is theta, which means that angle there is theta. So the one that I want to find out is theta, right? That's the angle that's between the 2 planes, which is this angle or this angle that I've got here. How would you describe those yellow angles that are up top here? What would you say? How would we say what they are? Not necessarily like vertically opposite angles. I mean, imagine that the plane wasn't even there. And I'm interested in finding out these, because if I find out these, I find out what this is. What are these angles? What have they got anything to do with? Maybe I'll just say, because I think it's hard for me to ask this question. these are both the normals, right? These these yellow ones I've drawn here are the acute angles between
No.
the normals.
Yeah.
Okay? The acute angles between the normals is the same as this one that I've got over here. So if I want to find the angle between the planes, all I really need to do is find the acute angle between the normal. I'm going to show it to you in a slightly different way to convince you. So the angle between the planes, cos theta, is just going to be n1 dotted with n2 divided by the modulus of n1, the modulus of n2, and I'm putting the modulus signs in to make sure it's acute. So another way we could have thought about that is if this is n1 and this is n2, we know that that's 90 and that that's 90. This is the one that we want to find out, which is theta. So this one over here must be 180 minus theta. But do you remember when you do the calculation, if you get an obtuse angle, you just do 180 minus theta. So if you're trying to find out that one over there, 180 minus theta just flips you back and forth between these two angles that you have here. So if you just take the modulus, you're guaranteed to get the acute one, okay? So this is the thing that we need to know here. That's,
Do you get these formulas in the book?
no, but they're actually quite easy to remember. And I'll write them all down on the board so you've got them all in one place as well. In fact, why don't we just do that now? So this is plane and plane. Cos theta is d1 dotted with d2 over the modulus of d1, the modulus of d2. And I'm going to say add in the modulus signs for acute. And what does this one tell us about?
3 lines.
2 lines. So this is a line and a line.
And sine for line and plane.
And then it's going to be sine theta. What were the things that we had inside for sine though?
N dot.
We had n dot b. For some reason we've got direction there as b and the direction here is d, but it doesn't really matter. Over modulus of n, modulus of b, and we do the modulus of all of it. So that is the line and a plane. And there's no more combinations.
Is there always acute angle?
They will always ask for the acute angle, right? 9 times out of 10. So here's an example. Find the acute angle between these planes. What is the value of n1? What is the value of n1?
3 minus 2, 4.
Good. 3 minus 2, 4. The value of n2?
5 minus 4, 2.
5 minus 4, 2. Do I have to do this bit?
No.
I'm going to do it quick. So cos theta is 3 minus 2, 4, dotted with 5 minus 4, 2. And I'm going to take the modulus out, but actually I don't need to take the modulus because I can see I'm not going to have a negative all over. What's that? 25 root 29 and root 25, 31, 35, root 35. So the numerator is 15 plus 8 plus 8, so it's 31 over root 29 root 35. And so theta is whatever it is.
In the exam, can you just quote the formula, or do you have to do any like reasoning?
Absolutely, you just quote the formula. So the acute angle between those two planes is 13.3 degrees. Ishak?
Is it root 45, not root 35?
Yeah, my mistake. So that's going to change our answer a bit. It is root 29 though, right? I hope so.
You get 30, yes. 30.9.
That's the only mistakes you can make in these questions, is the rushing. So you can imagine these two planes big surfaces, and the angle between them is an acute angle. It's 30.9 degrees. Obviously, the angle could also be an obtuse angle if you're looking at a different bit, but that's why we have to ask for one of the angles, because you get a bit of both, okay? So we're not going to do the intersections of two lines. You can now do exercise 9D, do a mixture of some of the ones about two lines, and some of them about a line and a plane, and some of them about the two planes. You can see all the different questions that there are for that. And I think that's us pretty much done, okay?